All right, we have a of x is defined as the integral from 0 to little x of f of t dt, and capital B of x is defined as the integral from 2 to x of f of t dt. And here's the graph of f of x. So all they've done is change the variable to t. So if you want, you could relabel it f of t, and you could call this t if that helps. Okay, so we are integrating from 0 to x in this first one. I think it's actually easier to do b of x first. We're going to start with b of x here, then we'll go back to a of x. So b is defined as the integral from 2 to x, and it says down here, it only has to be valid on the interval from 2 to 4, meaning x is going to be between 2 and 4. This upper limit of integration, in other words, we're guaranteed is somewhere between 2 and 4. So I'm just going to draw it at a random value. How about right there? So that's x. So b of x, in terms of an integral or an area, b of x means the net area under the function from 2 to x. That's what a definite integral is its net area. So this means net area under f from t equals 2 to t equals x. So if you want to sketch it, that is referring to just this area right here from 2 to x. We don't really care about anything that happened before 2 because our integration doesn't start until 2. Our lower limit of integration is 2. Okay, so that area is a rectangle. So it's the area of the yellow rectangle here, which has a constant height of 5 in this example, and its width is from 2 to x. So its width would be x minus 2. Okay, and that's it. That's b of x. You could distribute if you want and get 5x minus 10. Now a of x, for that part, we're going to integrate from 0 all the way to x. So we're also going to include all of this net area and this area. Okay. Now this net area is easy. You can just literally count the squares right there. So that part of it from 0 to 1 is negative 5. Now the integral from 1 to 2, you can see this triangle right here has the same exact area as this triangle, only one is negative and one is positive, so the net area there is 0 because those two triangles cancel. Okay, so what I'm doing, and I ought to write, is I'm splitting this integral from 0 to x up into, in my mind, I'm splitting it up into a sum of 3 integrals. This is the integral from 0 to 1 of f of t dt, plus the integral from 1 to 2 of f of t dt, plus the integral from 2 to x. And I'm doing that because the integral from 0 to 1 is just that rectangle, but it's below the x-axis, so negative 5. The integral from 0 to 2 is 0 because those triangles cancel. And then the integral from 2 to x we found up here is 5x minus 10. So this integral is coming from that integral. That integral is 0 and that integral is negative 5. So then simplifying, we just get 5x, looks like minus 15.